So we're going to look at something called the Born-Haber cycle. And all it is a way of using thermodynamics that we've seen before and Hess's law to calculate that lattice energy quantity that we wanted to. So I've drawn a little axis here. This is enthalpy increasing. So these are high energy, less stable things. These are low energy, more stable things. I've drawn a little line right here that represents a certain amount of enthalpy. And we're going to start off with these things as our reactants. And it'll become clear later why we're doing that. So we're going to start off with sodium metal, just plain old sodium metal, sodium solid. So here's some sodium atoms stacked up. And we're going to also start with a half mole of chlorine gas. So here's some Cl2 molecules and stacked up there. Now we want to make sure that we have, because we're going to be making sodium chloride, we want to make sure that we have one chlorine atom for every sodium atom. Because chlorines occur in molecules, Cl2, we only need a half mole to get 1 mole of Cl atoms. So we have 1 mole of sodium atoms and a half mole of Cl2, so 1/2 times 2 gives me 1. So we have 1 mole of chlorine atoms. So we're going to put these two guys, these elements together, they're going to react and they're going to make sodium chloride, the ionic compound, NaCl. So that's a reaction that you can actually measure. The enthalpy change for that reaction is called the enthalpy of formation. You've seen that before. Remember, formation is when we make 1 mole of a compound from its elements in their most stable state. And sodium at room temperature and pressure is a solid. Chlorine is a gas, a diatomic gas at room temperature and pressure. So we can measure this reaction, and it turns out to be negative 411.2 kilojoules. Okay, so that's all well and good. So now we want to think about this lattice energy term. And so I'm going to add to my picture a little bit. So what I've drawn is another line, a different enthalpy level, much higher. And so what I've done is I've taken this ionic compound, the sodium chloride, and I've pulled the ions apart and thrown them into the gas phase. So here we've got the sodium cations and the chloride anions, and they're separated from each other. I've broken all the ionic bonds. So if I were doing the process this direction, starting with this enthalpy and going down to making the sodium chloride, well, that is exactly our lattice energy reaction. Sodium ion gas plus chloride gas yields sodium solid. Well, that's what we have here, sodium chloride solid. So that is the lattice energy. So you see we're getting a little bit close. We've got the lattice energy on our energy diagram. So now what we have to do is think of some way that we can add other energies in here to create a cycle that goes around in a circle, and that will let us calculate this unknown piece. Because we know if we start here in energy and we work our way around back to this same point, the total energy change will be 0. That's part of Hess's law. And that's the beauty of having a state function. So you start in one state, you do some process, you end up back in that same state. The total enthalpy change has to be 0. So we're going to use all these enthalpy changes to calculate the lattice energy that we don't know. So in the next part of this video, we will go through and do those steps.